So assuming that this is a continuous function and we know it crosses the x-axis, and we would like to estimate r is the root. We would like to estimate this, let's say, with 6 decimal places. And you can say, that's no big deal. I will go to the calculator, I will put the function in, and then I will use second and calc. I will use the 0 of this function, or the intersect with the x-axis, and I'll find the solution. What's the big deal? What are you talking about? I can find with the calculator any solution I want. True. Absolutely correct. However, there is a method called Newton's method that is an application of differentiation, and it will solve for us any equation with any number of decimal places. Keep in mind, we still have to use a calculator, so I think 8 or 9 digits is the maximum that the calculator will give. Okay, so what is the method all about? First, I have to show that through the intermediate value theorem that we discussed a long time ago for continuous functions, f of a is positive and f of b is negative, or vice versa. F of a is negative and f of b is positive, so then it's guaranteed that there is a solution. So 1 unit interval. So let's suppose I show that there is a solution between a and b using the intermediate value theorem. The function is continuous, and it changes sign at a is negative and at b is positive. What does Newton say? Newton says this: start with one or the other. There are some restrictions, but for now, start with one or the other. Okay, so let's say I start with this value. This is my initial value, x0. So this is my x0. I start with it, and I determine this point, which basically is x0 comma f of x0. It's on the function. And I will draw a tangent line to the graph of f of x, extending the line to cross the x-axis. This will be x sub 1. Your book says that this is the first iteration. I call it the initial value. It's up to you. And this is, for me, the first iteration of the method. So obviously, if I start with x0, I'm far away from the solution. But once I construct or I determine this point and I construct the tangent, that's what we all talk about in calculus, tangent, then I will be able to create or determine a better approximation of the root. See, even on my graph, x0 is far away from r, but x1 is much closer. But how do I determine this point? How do I determine x1? Because the point is x1 comma 0, right? So how do I determine this? Okay, so first of all, the slope of the tangent line, I have 2 points now. I have the point x0 comma f of x0, and I have the point x1 comma 0. And I also have the slope of the tangent line, which is f prime of x0. But this is the same thing with 0 minus f of x0, or vice versa, it doesn't matter. F of x0 minus 0 over x0 minus x1. So f of x0 minus 0 over x0 minus x1. What did I do? I wrote the slope of this tangent line in 2 ways. as f prime of x0 and f of x0 minus 0 over x0 minus x1, because I have 2 points. Of course, from here, I'm interested in finding x1. How do I do that? Cross multiply. So x0 minus x1 times f prime of x0, just algebra, equals f of x0. I will divide by this. x0 minus x1 equals f of x0 over f prime of x0. And in order to determine this, I will move this here and this here. And this is it. So for x1 will be x0 minus f of x0 over f prime of x0. This is the first iteration. Can anyone guess the second iteration? How do I get it? Well, I start at x1. I draw and I determine this point, which is x1 comma f of x1. I draw the tangent, and I get with x2 even closer to r. And I repeat and repeat and repeat till I get to r. So can anyone guess r2? I'm sorry, x2. x1 minus f of x1 over f prime of x1. Can anyone guess x3?
X2
Of course.
minus f of x2
Right.
over f prime x2.
Good. So what is potential problem? Make sure that f prime of x0 is not 0. If you choose an initial value that makes the derivative 0, you will never get anywhere. Okay? So in general, xn plus first iteration will be xn, because this is one less than the other, minus f of xn divided by f prime of xn. And this is Newton's method. Unfortunately, I don't think in 2 minutes I can show an example, because I need to show the calculator how to enter it in the calculator. But on Thursday, we're going to have plenty of examples with this. And there is only one section left, which requires the entire session.